Good morning, everyone. Let me ask you something. Have you ever felt how summers are getting hotter each year or noticed unpredictable rainfall patterns? This is not just nature's mood swings, it's the serious impact of global warming. Global warming is mainly caused by greenhouse gases like carbon dioxide, methane, and nitrous oxide. Since the Industrial Revolution, our average global temperature has already risen by about 1.1 degrees Celsius. That may sound small, but it has massive consequences on glaciers, sea levels, and ecosystems. If we cross 1.5 degrees Celsius as warned in the Paris Agreement, climate change could become irreversible. Most of this warming comes from energy generation, which produces nearly 70% of global carbon dioxide emissions. That's why finding ways to minimize it is both urgent and essential. Now, let's dive into how we can actually make that change. The first major solution is simple yet powerful: switch to clean energy. Think of solar panels capturing sunlight, wind turbines spinning in open fields, and dams generating hydroelectricity. These renewable sources produce electricity with little or no carbon dioxide emissions. For example, a solar cell can achieve an efficiency of about 15 to 20%. Wind turbines convert almost 30 to 45% of wind's kinetic energy into usable electricity. That may not sound like much, but when scaled up across a country, it can replace thousands of coal plants. India alone has the potential of producing more than 1,000 gigawatts of power from solar and wind combined. Just imagine, that's like powering hundreds of millions of homes without adding carbon to the atmosphere. As you can see in the comparative emission diagram, a coal plant releases tons of coal per unit of electricity, while a solar farm produces almost none. That's why renewables are our biggest hope for the future. The next solution doesn't need new technology, just smarter use of what we already have. This is called energy efficiency. Efficiency is the ratio of useful energy output to input energy multiplied by 100%. For example, LED lamps consume almost 80% less electricity than traditional bulbs. Smart electrical grids cut transmission losses from around 8% down to below 5%. And in buildings, simply using insulation reduces the energy required for heating or cooling by nearly 40%. So, higher efficiency doesn't just save energy, it reduces demand, which means fewer fossil fuels are burned and less carbon dioxide is released. In short, when we use energy wisely, every saved watt becomes a step against global warming. Now let's talk about a fascinating but slightly advanced idea: carbon capture and storage, or CCS. Imagine trapping carbon dioxide before it even enters the atmosphere. CCS systems can capture up to 90% of core emissions from factories and power plants. One method involves chemical absorption, where carbon dioxide reacts with quicklime. CaO plus CO gives calcium carbonate, CaCO, a stable, solid form. This captured gas is then transported and stored underground in geological reservoirs like old oil fields. Of course, CCS is expensive and requires careful monitoring to prevent leaks. But it acts as a bridge until renewable energy becomes fully dominant. Picture the diagram here. CO is captured at the source, compressed, transported, and finally stored safely underground. It's like putting carbon dioxide in a vault so it can't harm the atmosphere. But here's the truth: technology alone isn't enough. We also need changes in our daily lives and government policies. A classic example is the 3Rs: reduce, reuse, and recycle. By recycling materials, we avoid the massive energy costs of producing them from scratch. Forests also play a vital role. They absorb about 2.6 gigatons of carbon every year. That's why afforestation and reforestation are crucial carbon sinks. On the policy side, tools like carbon taxes make polluters pay for their emissions, encouraging cleaner technologies. And simple habits, like using public transport, reduce per person carbon emissions drastically. So remember, every small choice we make, from carrying a cloth bag to planting a tree, multiplies into a big impact when adopted by millions of people. Let's work through an example to see the numbers. Suppose a household consumes 1000 kilowatt hours of electricity per year. If that electricity comes from coal, with an emission factor of 0.9 kilograms of coal per kilowatt hour, the total annual emission is 1000 multiplied by 0.9, 900 kilograms of carbon dioxide. Now, if the same energy is produced by solar panels, the co-emission is practically zero. So, the household saves 900 kilograms, or nearly 1 ton of coal every year. Now imagine 1 million homes doing this, that's almost 9 lakh tons or 0.9 million tons of carbon dioxide avoided. This example shows how even small household decisions, when scaled up, make a measurable difference in fighting global warming. So to sum it all up, minimizing global warming requires a mix of science, technology, and lifestyle choices. We've seen how renewable energy replaces fossil fuels, how energy efficiency reduces waste, how carbon capture locks away harmful gases, and how individual and policy actions strengthen the fight. Equations help us see the connection between co-concentration, radiative forcing, and temperature rise. But beyond the math, it's about responsibility, ours as individuals and as a society. The crux is simple. Every step we take, from installing solar panels to turning off unused lights, contributes to planetary stability. Together, we can bend the curve of climate change. I hope you now have a deeper understanding of how we can minimize global warming's impact. In our next session, we'll explore another exciting concept in physics. Until then, keep observing, keep questioning, and keep caring for the world around you.